Number 10 is asking us to solve and graph two inequalities again. The first is 9x is less than or equal to negative 45. The second is 2x plus 17 is greater than 29. I'll solve them one at a time again. To undo a times 9, we divide 9, and we find that x is less than or equal to negative 45 divided by 9, which is negative 5. You can circle that, and because it's a less than or equal to, we should color in the circle. And remember, less than is to the left side. The next inequality, 2x plus 17 is greater than 29, can be solved first by subtracting 17. We find that 2x is greater than 12. And when we undo the times 2 with divide 2, we find that x is greater than 12 divided by 2, which is 6. So you can circle the 6. Because it's only a greater than, we don't color the circle in. And remember, greater than is to the right. Now that we're done solving both, we can shade the number line, and our answers should go away from each other. So our possible solutions are represented by the shaded areas. Number 11 is an absolute value equation. The key to these is to split them into two problems. You take what's in between the bars exactly as it's written, and once you should set it equal to a positive answer, and once you should set it equal to a negative answer. So notice the equation on the left side is the same in both cases, 8x plus 4. The difference between the equation is once it's equal to regular 28, once it's equal to negative 28. And then you just solve each equation. Subtract 4, 8x equals 24, and then divide by 8 to find that in the first equation, x equals 3. Then you can solve the second equation with the same steps. Subtract 4. This time we end up with 8x equals negative 32, and divide by 8 to find that this time x equals negative 4. These are the two solutions, x equals 3, x equals negative 4. Number 12 follows a similar concept. We're going to create two equations. 5x plus 10 equals 15x. Our second equation is going to be 5x plus 10 equals negative 15x. So once again, when you have the absolute value bars, you're writing two equations. Once with a positive answer, once with a negative answer. These equations have variables on both sides. So I like to move the smaller variable to the other side. So we'll find that 10 equals 15x minus 5x, which is 10x. And we divide by 10 to find that in this case x equals 1. The second equation, I'll move the 5x again, subtract 5x. We'll find that 10 equals negative 15x minus 5x, which is negative 20x. And then to undo a negative 20 times x, we divide by negative 20. This time we find that x equals negative 1/2. When you have a variable on both sides of an absolute value problem, what you need to do is take the answer and check it with the answer of the problem. So I'm going to change x to 1 to make sure this is a legitimate solution. 15 times 1 is 15. Because the answer is positive, this is a legitimate solution. Because remember, the answer to an absolute value equation must always be positive. With the second solution, if I were to change x to negative 1/2, do 15 times negative 1/2, this is going to equal negative 7.5. The answer to an absolute value equation can never be negative. Therefore, this solution is invalid. You can just cross it off. To get total, full, correct answer, you should have x equals 1 and cross off the second solution of x equals negative 1/2.